Okay. Good afternoon, everyone. Welcome to Fem Afrique. Um, Today's section, we are going to discuss on what you call indices. Indices. Okay. So we'll start with indices is basically powers of numbers. When you have powers of numbers or exponents of numbers, how are you going to solve it? So in every game, you have rules. So this one too, I'll show you some basic rules when you are dealing with powers or exponents of numbers. So first of all, I will start with rules. So you have these rules, right? You have some basic rules. Let's say you have a number. I'll just make some generalization by picking some numbers. Let's say A. You have this A. And then this A exponent 1. So what this means is any number exponent 1 is the same number. So A exponent 1 is A. A exponent 1 is what? A. That's first rule, one rule. So this rule actually guide you when you are solving any expression involving powers or exponents. The second rule is any number apart from 0, exponent 0 is what? 1. That one you can prove it, but it's not a level. So any number exponent 0 is equal to 1. But A shouldn't be 0. So apart from A being 0, any number exponent 0 is what? 1. And then the third rule is multiplication rule. When we have, let's say, A times A, this one is exponent B, this one is exponent C. For this rule, what it says is the basis should be the same. What do I mean by basis? Any number that this one's A, this ones are the basis. They are the numbers that carries the exponents or the powers. So they are the basis. So if the bases are the same and they are multiplying, then you add the exponent. This is a multiplicative rule. So this one is equal to, since the bases are the same, I'll just write 1 and then B plus C. So when you have expression which involve powers and then the bases are the same, then you simply add the powers, right? So this is the third rule. Fourth rule has to do with division. Division. Division also takes into consideration the same bits before you can operate or use this formula. So let's use the same thing. So A exponent B divided by A exponent C. So for here, this rule states that or says you maintain the numerator, which is A exponent B. Since the bases are the same, you write 1 and then you subtract the exponent. So this one we have B minus C. B minus C. So this one is for division, multiplication. So what about addition? It doesn't hold for addition and subtraction. That's how it is. So these are just the basis like of indices or powers of numbers. So I'll give you one example and then we'll try to apply these rules and solve it. Okay, so let's assume example 1. This example 1. Let's say we have 2 exponent 3 times 5 exponent 2 times 3 exponent 0 times 2 exponent minus 1. So when you have something like this to simplify, what comes into your mind? You just go back to your roots or the guidelines. So these are the rules for the game. So first of all, let's check whether we have the same basis. Now, from here you can see that we have 2, 2. That means these two, we have the same basis. It means we can put them together or group them. So from here we have 2 exponent 3 times 2 exponent negative 1. Is there any 2? No. Then let's move to the next one, 5. So 5 exponent 2. There's no 5, so move on, 3 exponent 0. So this one, you go back to your roots. Which roots or which rule is applicable over here? So first one, let's deal with this. Since the bases are the same, the rule says we should add the exponent. So I'll write this one of it. So 2 exponent 3 plus minus 1, which is the same as 3 minus 1, times 5 exponent 2 times 3 exponent 0. So 3 exponent 0 comes back to root 2. Root 2 says any number apart from 0, exponent 0 is what? 1. So this one simply be 1. Right? So now, let's simplify it further. So you have 2 exponent 3 minus 2. So let's simplify the exponent. 3 minus 2 is what? Minus 1 is 2. So we have 2 exponent 2 times 5 exponent 2 times 1. 2 exponent 2 is 4. Then 5 exponent 2 is 25 times 1. So 4 times 25 times 1 is equal to 4 times 5 is 20, 0 remainder 2. 4 times 2 is 8 plus 2, 10 times 1. So we have 100. So we have 100. So simplifying this using indices, we had 100. And then sometimes in your question, they'll ask you, leave your answer in a standard form. That one will come to it. So let's address ourselves with the indices and then we move on to how to represent these solutions or answers or numbers in standard form. So this is about multiplication. Let's take one example under division and see how it works. So let's assume you have this expression. So evaluate example 2. Let's say evaluate the expression. Then we have, let's say, 3 exponents, 5 times 2 exponents, 6 times 3 exponents, 5 exponent 1 is negative 1, 4 divided by 3 exponent 2 times 5 exponent 0 times 2 exponent 4. Okay, so let's assume that in your objective or whatever, section B, you have something like this expression. Simplify this expression. So first of all, you check through your expression. You've seen that there are powers. There are numbers carrying other numbers. So there are powers. So what do? We try to deploy the method of indices and then the rules. So you just keep these rules at the back of your mind and then use them to solve or to simplify your expression. So let's evaluate example 2. So from here, we have this 3 power 5 times 2 power 6 times 5 power negative 1, all divided by 3 power 2 times 5 power 0 times 2 power 4. So first of all, what we do is, since this one is dividing, we first check the top one. Are there any common bases? No, there are no common bases. So we can just leave it like that. The down one, there's no common bases. So now we move to fourth rule, which deals with division. So the division, what you do is you group those with a common base and then we apply our rules. So this one can be written as, first of all, you keep the numerator, so it's 3 or 5, and then the denominator. So we subtract the exponent, so we have minus 2. So we are done with 3. Let's move on to 5, 2. So you have 2 here, 2 exponent 6. Let's check the denominator. The denominator is what? 2 exponent 4. So since it's dividing, we subtract the exponent. So 6 minus 4. I think we are done with 2. Let's move to 5. So times 5. The exponent is minus 1. And then from here, the exponent is what? Minus 0. And this one is the same as 1. So you can choose to maintain it. Because when you subtract, you get the same thing. So from here, we have, okay, let me move to this place. Sorry. Okay, let me finish this. So from here, we have 3 exponent 3 times this one, 2 exponent 2, then times 5 exponent 1. So 3 exponent 3 is equal to 9 times 4 times 5 exponent negative 1. And then 5 exponent negative 1 is the same as 1 over 5. So from here, I can write 9 times 4 times 1 over 5. Okay, let me move it here. So I'm moving this one to here. So we have 9 times 4 times 1 over 5. So 9 times 4 is 45. Sorry, 36. 36 divided by 5, which is equal to. So this one, let's use long division. So we have something like this: 36, then 5. We know that 5 goes to 30 how many times? 5 goes to 36. How many times? 7. 7 times 5, 35. When you subtract, you have 1. 5 cannot go to 1, so we introduce our decimals as 0. 5 goes to 10, 2. 2 times 5 is 10. So from here, we know that our answer is equal to 7 points. So when you simplify this, you have 7.2. That's the final result. So this is how the division also works. But one thing you have to know is, it doesn't hold for addition and subtraction. You can't say 2 exponent 4 plus 3, let's say 2 exponent 6 is equal to, is not equal to 2 exponent 10. These two rules calls for addition, multiplication and division. So you should bear it in your mind. It doesn't hold for addition or subtraction. Okay, that one is just short. Okay, then since most of our question, BC question, they will ask you to evaluate expression and then at the same time you leave your answer in a standard form. I would like to introduce you how to write your answers in a standard form after evaluating your expression. So let's look at what a standard form is or how can we present these results in a standard form. So when we say standard form, we are basically talking about writing numbers in scientific form or notation. That's basically what. It's the same thing, but we are just writing it into another form, more scientifically or um, widely accepted way. So we have this standard form, standard forms of numbers. So standard form of numbers is the rule is we are just trying to write, let's say numbers. Let me take this. Let's say 200. We want to write it in the standard form. What we want to do is we want to express these numbers between 0 and 10. We want to write it between 0 and 10, which comprise the first part, and then the second part, that number should be multiplying 10 exponent something. So when we have 200, you see these two, 2 is between 0 and 10. So I have my 2 here. So after getting my that the number, then I'll introduce a point, decimal point. So from here, then I'll introduce the decimal point. So 2 points, then 0, 0. So the next thing is how many times or step have I moved before I introduce the numbers. So from here, 200, no, 200 is the same as 200.0, right? So this is the decimal. So we move 1, 2 before we were able to locate that number. So I've moved 1, 2 from right to left. So this one we have 2.00 times 10. We are dealing with base 10. So the exponent tells us how many times have I moved either from right to left or left to right. So when you move from right to left, then your exponent should be positive. But when you move from left to right, then your exponent will be negative. That's why you have some expression times something exponent, negative 2, some exponent, positive 2. So this one, how would it be? We are here, so we move 1, 2. We have moved from right to left, and then it should be positive. And then from left to right, we should get negative. So this one, we move from right to left. So here we have positive 2 because we move to right. So 200 is expressed, can be expressed in 2.00 times 10 exponent positive 2. When you multiply this, you get the same thing. But this one is more accepted way, more scientific. Because those who will be moving to science, chemistry, like physics, they like to write their results in terms of scientific notation. Let's say 2 point something times 10 exponent negative something something. Because most of the time you may come across a huge number that you cannot write them out explicitly. So you use this scientific notation to simplify it. Another importance of this scientific notation is to compare numbers. So the power will check whether this is bigger than this. Sometimes when you have 0.00 something, you don't know how large or small it is. But when you're able to write it in this form, you can compare those two quantities. Okay, so let's look at one or two examples under this. So, example one, simplify. Simplify 1,200 multiplied by 1,600 all divided by 800. And then leave your answers or your answer in a standard form. Leave your answer in a standard form. So first of all, what you have to do is you simplify this and then you leave your answer in a standard form. Okay, so simplify this. You first multiply this and then you divide it by 800. Or you can convert it straight to standard form and then you simplify. So it's two things. It's either you simplify this one first and then afterwards you convert your answers to standard form, or you put this one into standard form and then you simplify. Okay, so let's look at it. So let's simplify first before we convert it to standard form. So you have 1200 times 1206. So let's multiply 0, 0, 0, 0. This one is 0, multiplied with 0, 12, 2, remainder 1. And this one is 0, 0, 4, and then 2. After again add, so you have 0, 0, 0, 2, 5, 2. So this is what you get at the top. And then afterwards, then you divide by 800. So you have 2500 25200 divided by 800. So you will see that this will cancel this, and then this also will cancel this. So we have 2520 divided by 8. So this one I can use long division to arrive or to simplify. So we have something like this: 2520 divided by 8. 8 goes to 24. 8. 25 how many times? 8 to 16, 8, 3, 24. So we have 3. 8 times 3, 24. So 24, 25 minus 24 will give you 1. Then we shift the rest of the numbers. So we have this. So now 8 goes to 12. How many times? 1, 8 times 1, 8. The number is 4. Then 2 is 0, 8. 8 goes to 40. 5 times. 8 times 5, 40. Then 0, 0. Since there is no remainder, then we stop. So our final answer is 315. So 315 is the simplification of this. And with this, your question states or states leave your answers in standard form. So let's express this one in standard form. So 315, you want to express it in standard form. So this is the same as 0. So first of all, our first number should be between 0 and 10. So these are first number. This is what? 3. It falls within that range. So let's move. 1, 2. Then we take the dots. So we have 3 dots, 1, 5, and then exponent. How many times have we moved? We've moved 1, 2, and from right to left. So when it's from right to left, then your exponent of n will be positive. So you have this. So our final answer is 3.15 times 10 exponent 2 times 10 exponent 2. So you can try this. Convert this one to standard form, all the numbers, and then simplify. That one will give you the same results. That one will give you the same results. Okay, let's pick one more example and call it a day. Okay, so that I ask you, um, what's what is the value for x in the expression? Let's say you have 10 exponent x is equal to, let's say, 1000. So this one you just use indices or standard form notation. So first of all, you concentrate on this. So how will you express this one in terms of standard form? So you have 1000. So the same as 1000 and 0. So these are dots. So how many times will you move to locate your number? And don't forget that the number should be in between 1, 0 and 10. So these ones qualify to be the number. So let's locate this one. So you move 1, 2, 3. And then you move from right to left. So you have 1 dot 0. This one a lot of zeros, so we write this one times 10 exponent 1, 2, 3. So this is what we have. So we just compare this to this. And 1 times 10 is the same as 10. So this one have 10 exponent 3. So you have 10 exponent x equal to 10 exponent 3. And since the bases are the same, then the powers should also be the same. So that's why x, then our x is equal to 3. And this mostly comes in objective. So it's about you knowing your decimal places and powers of numbers. Okay. It seems you are dealing with positive. Let's take one example that we move from, take our bet from negative. Okay, evaluate. Evaluate 0.035 times 1.200 is 15. So we have been asked to evaluate this. So first of all, let's try to convert all this one into standard form. So when you pick this one, where can we locate our number? Our first number should be between 0 and 1. So from here you can see that this one, and then this is the decimal. So you move 1, 2, and then we are moving from left to right. So this one can be written as 3.5 times our base, which is 10. Then you move 1, 2 from left to right. That one will be negative, negative 2. And then times this is our decimal point, right? So how many times will we move for us to locate our significant number? 1. So we have Yeah, I'm just checking whether the question is correct. I want to complete that one too. Stand up. So what you do is your next step, you multiply this by this. Then so 1.20015 times 3.5. So 3.5. Yes, no, good. Three times 5 is 5. That should convert it to standard form. Standard form. We are just evaluating it. I just converted the first one to standard form, then the second one. I just want to have a simple one. Yeah.
I think, okay, I'll write them as whole numbers and multiply them with sugar.
Yeah, that is more.
Yeah, but it depends. Because they are quite large numbers.
Yeah. Okay, because when you multiply them inside. So this time this is same as let's multiply 2 by 10. So 10015 times 35. 5 times 5 is 5, and we have 2, so we have 7. 25. So I write my 5 with the 2. 5 times 1 is 5 plus 2 is 7. 5 times 0 is 0, times this is 0, this times this is 10. So 0 remainder 1. 5 times 1 is what? 5 plus 1 is 6. Again 3. 3 times um, 5, 15. Remainder 1 is 1 give me 4. 3 plus 1 0, 0, 6, and 3. So when you add them, you have 5, 4, and 1, 5, 0, 0, 2, 4. 2, 4. So from here, since we multiply it by 10, we move the decimals. So we have 4.200525. So we have 4.200525 times 10 exponent is negative 2 times 10 exponent negative 2. So this will be the final result. And we simplify. This is 1.2. And then we move 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But since the other one is also multiplied by 10, then we move another one. That's why we have 4.200. Because the decimal place for this is 4, and then this one is 1. So when you add them, you have 5. So you have to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, 5 and 1, 6. So you have 4.2005525 times 10 exponent negative 2. So when you evaluate this is what you get. So that's how standard basis makes. That's how standard basis makes. Okay, so this is basically um, what I want us to know today. So today what we did is indices, and then these indices we have this set of rules. So first one, any number exponent to 1 is the same number. You have to bear that one in your mind. And then any number apart from that number being 0, exponent 0 is 1. It's 1. And then you have these two major rules, which when you have a number carry another number, but they have the same base. Let's say a exponent b times a exponent c. Then the rule says maintain 1, and then you add the exponents. So you have a exponent b plus c. And then the second rule also, the fourth rule also deals with division. This one is multiplication. This one is division. So first of all, to make sure that the bases are the same. And what we say the base is the number that carries the powers. So when you check the number that carries the powers, if they are the same, then you apply this rule. So this one you have a power b divided by a power c. The rule is maintain the one in the numerator, which is a power b, minus the exponent of the denominator, which is minus c. So that's how it is. And after getting all those results, we know that any number can be expressed in a standard form. And then the standard form is basically the scientific way of writing numbers. So when you have number like this, 1,000, what we want to do is first number should be in the range of 0, between the 0 and 1, and 10, sorry. So when you pick this number, let's say 1,000, 1,000 is the same as 100.0. So these are decimal move. So how many steps will we move to locate that number? So when we stand here, you move 1, 2, 3. Then when you move from right to left, the exponent of the 10 should be in positive. So that's why we have 1 times 10 exponent 3, because we've moved from right to left. But when we move from left to right, then the exponent of 10 should be negative. So that's basically what we did today. So when you go through the past question, mostly you find these questions in objective and some part of your section B. So you just apply the rules and then you solve it. I wish you all the best in your studies, and then coming exam. Work hard, everything is achievable. Nothing is too difficult. You just keep practicing, right? Okay. See you next week. God bless you all.
Say right there.
I've ended.